Hey everyone, welcome back to my YouTube channel. If you are seeing me for the first time, this is Santosh Pothraju. Today we are in a Kafka tutorial playlist. To be honest, this is not the first video. We already gone through few videos like explaining the Kafka terminologies and explaining the deployment strategy, and also we spoke about the Kafka architecture. If you missed the earlier videos, I highly recommend start watching from the beginning of the playlist. But if you are interested in knowing only the producer internals, this is the right video for you. With that said, let's get started with our video. So just to recap, as we already gone through few videos in this course, today we are going to spend some time on producer internals. To be honest, before we go into the producer internals, we are going to touch base on the partitions, replications for HA and fault tolerance. To be honest, we already covered these concepts in the Kafka terminology, but these are very, very essential to understand the Kafka producer internals because these are kind of interlinked. So we are going to touch base a few minutes on these partition replications one more time, and then we will spend some time on the producer internals. With that said, let's open our whiteboard or blackboard, whatever we call it. And here, let's try to get some idea using some fundamental concepts. Okay. HA for high availability and FT for fault tolerance. And these two concepts we are going to cover first. Um, so for a minute, forget about the number of servers and all that, and let's talk about the partitions. As we already know, the Kafka is going to have the topics, and within the topic, we are going to have some partitions. For example, let's take a post as our topic, and if you watch the Kafka terminology, you know what I'm talking about here. So let's take post as our topic, and within the post, let's assume that we have three partitions. And as you already know, the partition sequence will start from the 0. So here, let's consider this is a P0 partition, and this is a P1 partition, and this is a P2 partition, right? So what is the replication factor? We already spoke about the replication factor in Kafka terminology. Just to recap, replication factor is the number of copies we want to maintain for every single partition. So in the production, we are going to give this as a replication partition 3, but you can also increase it to 4, 5. It depends on the criticality of the environment. But ideally, for any production environment, I think defining replication factor equals to 3, that is more than sufficient. So if we define replication factor equals to 3, what that means is every partition is going to have two more replica copies. Here, for every single partition, we are going to have two more replicas so that our data will be stored in three different places. So for example, for the P1, this is the main partition. In the main partition is also called as a leader partition. And these two partitions are the follower partitions or sink partitions. And here, let's consider that this particular partition, this is the leader partition. And for example, now let's talk about the server architecture. And here, let's assume that this is sitting on the Kafka controller 0. What that means is on the server 1. And here, let's consider this is the leader, and this is sitting on Kafka controller 1. And here, the last one, this is sitting on Kafka controller 2, right? So here, this is P0. For the P0, this partition, which whatever sitting on Kafka controller 0, this is the leader. When it comes to the P1, the second partition, which is sitting on Kafka controller 1, that is the leader. And when it comes to the P2, the partition which is sitting on the Kafka controller 2, this is the leader partition. So in this particular example, let's assume that Kafka controller 0 is down, right? So if Kafka controller is down, then eventually we are going to lose three partitions. So when it comes to the P0 partition, the main leader partition we are going to lose, and when it comes to the P1 partition, we are going to lose the follower partition, which is P1 follower partition, which is sitting on the Kafka controller 0, and on P2 also we are going to lose the follower partition. So what that means is even though we lost the some partitions here, whatever the replication, whatever the replica partitions we have here on Kafka controller, here let's assume that this is sitting on Kafka controller 1 and this is sitting on Kafka controller 2, and here this particular partition which used to be following the leader partition before, now this will be elected as the leader partition. So this will happen in the real time. So when this particular partition down, this particular partition which is sitting on the Kafka controller 0, once this is down, immediately the partition sitting on Kafka controller 1 for the P0 will be elected as the leader. And here we are not going to see any impacts because we lost only the follower partition. And on P2 also, we are not going to see any impact because we lost only the follower partition. So let's assume that Kafka controller is 0 back online. Now, maybe here, if we have 100 messages forward, like, the leader partition is 100 messages forward, then immediately this particular partition will become online, and then it will start becoming the in sync with the leader partition. So here also, we are not going to see any impacts because anyway, this P1 partition sitting on Kafka controller 0, this is anyway the follower, and immediately this will start syncing the rest of the messages. The same thing will apply on the P2 partition as well. So now let's talk about what is high availability, right? So you understand what is partition architecture here. Now let's talk about what is the high available. So let's assume that here I have some mobile application, and maybe let's take 3 users, and this is user 1, and here we have user 2, and here user 3. So these 3 users are using some social media platform, and if you recall our terminology video, let's assume that these 3 users are trying to post some message into the Kafka environment, right? So here, let's assume that these 3 users are trying to post the messages simultaneously to the Kafka platform. So when these users are trying to post the messages, let's assume that a Kafka controller went down. So even though Kafka controller went down, immediately the partition for the P0 sitting on Kafka controller 1 will become as a leader partition. So the main purpose of the leader partition is taking care of read and write operations to the partitions, right? So here, since with this particular partition elected as the leader partition, we are not going to see any impacts on the customer side. So when these users are trying to post the messages, immediately some other partition will become as the leader, and then this will start serving the needs, meaning reading the messages and then writing those messages into the partition. So this is called high availability. Even though something went wrong on the Kafka side, we are not going to see any impact on the customer side. So this is what we call as a high availability. When it comes to the fault tolerant, since we have replication factor equals to the 3, what that means is we have the data in 2 other locations. So in this particular example, let's say Kafka controller is 0, even though the primary or leader partition is down, we still have 2 more replicas here. So immediately some other replica will become as a leader, and then this will be start serving as read write operation. At the same time, when we are reading these messages from the consumer can read the messages from these follower partitions, because some other partition will become as a new leader, and then consumer can start reading the messages from the replicas. So in this particular situation, even though server is lost, we are not going to see any data loss. So that is what we are going to call as a fault tolerant. I hope we have very good clarity now in between high availability and the fault tolerance. And now let's talk about the producer internals, right? So within the producer internals, here in this particular example, these mobile applications are our Kafka producers, right? As we know, whomever generating the data to the Kafka environment, those we call as the Kafka producers. So within the Kafka producers, there are 3 modes possible. One, acknowledgement equals to 0, acknowledgement equals to 1, and then acknowledgement equals to -1 or all. So these are the 3 modes available within the Kafka producer. It doesn't matter that Kafka producer is some logging agent, or you are writing your own producer using Python or Java, whatnot. So these are the basic the modes available for the Kafka producer. Now let's talk about what is acknowledgement 0. So when this particular mobile application is trying to post some message into the Kafka platform, So this particular application is not going to wait for the response from the Kafka platform. So that's what acknowledgement equals to the 0. So this is ideal for if we need to fire some query, and if we don't have to keep track of the status, then we can definitely go with this acknowledgement equals to 0. But this may not be ideal for most of the scenarios, right? Because when I'm posting some messages, I need to make sure that message is successfully delivered into the platform. For example, I'm posting something into XYZ social media platform. I need to make sure that post is successfully posted into the platform, right? So that's where we are going to use the acknowledgement mode equals to 1. So in this particular mode, when this producer is writing some message into the Kafka partition, this reader partition is going to send the acknowledgement back to the Kafka producer. So in this situation, when response came back to the Kafka producer, then this can consider as that message is successfully posted into the platform. So that's what this acknowledgement equals to the 1 mode. So in this particular mode, Kafka producer is going to receive the message or reply back from the leader partition. When it comes to the acknowledgement equals to -1 or acknowledgement equals to all, in this particular scenario, this producer is going to wait for responses from every single in-sync replicas. For example, if I define replication factor equals to 3, then this particular producer is going to wait hearing the response back from all these replicas. So in my scenario, if this producer is writing to the P0 partition, and then this particular producer will wait until hearing the response back from P0 leader and the P0 replica 1 and the P0 replica 2. So this particular scenario is very, very critical if you are running into some business mission critical projects, or if you really need to make sure every replica is in sync with the primary partition. So if you have something need like that, then definitely we can go with it. But most of the scenarios or the real life scenarios, I think choosing the acknowledgement equals to 1, this can fulfill most of the requirements, meaning this will ensure the message is successfully delivered to the platform. And also when it comes to the latency, in the acknowledgement equals to -1 or here the latency will be very, very high because this producer has to wait until receive the response from every single replica. So in this particular example, which is acknowledgement equals to 1, this is super fast, and also this will give us a confidence to delivering that message into the Kafka platform. Okay, now I think the acknowledgement part is very clear. Now it's time to talk about other concept, which is batching. So this is also very interesting subject we have to talk about, because in most of the scenarios, we may have to send multiple requests into the Kafka environment, right? So for example, in this particular scenario, this may be simple mobile application, and most of the times we will post a single message into the platform. But when it comes to the some other architectures, we may have to send the bulk number of requests, maybe posting 100 messages at the same time, or maybe we have to post X number of messages based on the interval, right? So that's where we are going to use the batching. So within the batching, we have two criterias. Either we can do based on the numbering, like every 100 messages, whenever I have 100 messages on the Kafka producers, these I can flush into the Kafka environment, or every 10 minutes, like every 10 minutes, if I have to write the data into the Kafka environment, then the producer can wait for 10 minutes. And within the 10 minutes, if I have 50 records, and these 50 records can flush into the Kafka partition. So here, batching is going to help in many, many scenarios, because if we are really looking for the throughput, then batching can be significantly help in those type of scenarios. Because if I have to write record by record into the Kafka environment, then it can significantly increase the amount of time, the duration to write all those messages into the environment. But if I can write the multiple messages at the same time, then it can significantly improve the latency, and also throughput can be helpful in this particular scenario. And now, after we know the acknowledgement and batching, we have to talk about another concept, which is retry. So for any reason, if I'm posting some message into the Kafka environment, and for example, this Kafka 0, the partition sitting on the Kafka controller 0 is went down. And at the same time, some other Kafka broker also went down so that this producer is not able to send that message into the platform. So in that particular situation, we can define like how many times I can retry sending that message. For example, in the attempt 1, if I'm seeing some message like that platform is not able to receive, immediately the producer is going to try one more time, and then here maybe my platform is going to read that message, and then the successful acknowledgement will send back to the producer. If I define something like a retry equals to 3, what that means is that the producer is going to try 3 times in case of the failure scenario. So that's what it is. And just to recap, in this particular video, we spoke about Kafka partitions, high availability and fault tolerant. We spoke about what is the difference between high availability and fault tolerance. And then after we spoke about the Kafka producer internals. And just to recap, in the Kafka internals, there are 3 important concepts. One is the acknowledgement, the second one is the batching, and the third one is a retry. Acknowledgement, make sure like our message is successfully delivered to the Kafka platform. Batching is really helpful if you need to send the bulk number of requests to the Kafka platform, and retry will be very, very helpful in case of the stability problems are there on the Kafka end, so that we can successfully we can try multiple times to send that message successfully to the Kafka platform. With that said, let's complete this video. Just like how we spoke about Kafka producer internals, in the next video, we are going to connect on the Kafka consumer internals. So just similar to the Kafka producers, we have to understand few more things on the Kafka consumer. So we are going to discuss those things in the next video. So if you like this video, please don't forget to subscribe. I'm hoping that this is providing some value to you. Because of that, you are watching this video until the end. If you like this video, please don't forget to subscribe, and see you in the next video. Thank you so much. Bye.